Hi, everyone. Hope you enjoyed the conference so far. So my name is Xingyi Song. I'm academic fellow at the University of Sheffield. So today, I'm going to talk about the customizable NLP platforms for health and related research. So NLP has been applied in many healthcare researches. This including like electronic health record analysis. So researchers trying to build the relationship between the health-related interest to the patient history. Disease control during the COVID-19 pandemic, researchers trying to find out how social media impact the disease spread and control. Also, NLP have been applied in the systematic search, screening, and sifting process in the systematic review to speed up the review process. There are some researchers directly apply NLP for the diagnosis. More amazing thing about the healthcare NLP is some of the tasks are achieved close, even beyond human performance. So in 2017, some researchers already report some of the tasks like de-identification and coding NLP can achieve beyond human performance. For some more complex tasks like diagnosis, in 2019, Liang et al. Compare a bunch of NLP-based diagnosis compared with human. And for some of the diagnosis tasks, for example, the upper respiratory and the sinus diagnosis, NLP actually achieve better performance than human. Please be aware here, the human here is not like novice clinician. They are clinician with over 25 years clinical experience. So, but interesting thing is the number of healthcare researchers using NLP is not as many as we think. So if you search the text processing in the PubMed, you will find about 2,500 publications in last year, 2021. But if you compare with image processing, so if you search image processing in the PubMed, and you will find there are about 27,000 of publications mentioned about image processing. So what happened? Why people not using NLP in the healthcare research? There are many reasons. Yeah, some of people they not sure about what NLP can do, right? And some people knows about NLP, but they just don't trust NLP. But also there are some cases the people like to use NLP. People know NLP. They trust NLP, but there are some barriers stopping them using NLP in their healthcare research. More specifically, those barriers including the barriers to access the healthcare NLP applications. There are tens of healthcare NLP applications, software tools available online. Especially, they are listed in the GitHub. But the problem is, the healthcare researcher, healthcare worker, probably don't have same amount of computer science background as NLP engineers. So they probably don't know how to compile those source from GitHub, and they probably don't know how to use APIs, even REST APIs, from those NLP healthcare services. Okay, so that is the first barrier. And the second barrier is barrier to access the health-related data. So healthcare industry have a lot of data actually restricted. For example, the personal patient record, electronic health record. So those records are not allowed to move out of the hospital. And even inside of the hospital, this stuff not directly relevant to the patient is not allowed to access to it as well. But there are some data in healthcare industry as well. They are without any restrictions. For example, in the COVID-19, if a researcher wants to study the social network and how connect to the disease spreading and control. So there are billions of social media posts available online, but this also requires knowledge and the resources to collect, manage, and even apply them into the healthcare NLP applications. So that is the second barrier. The third barrier is the customization, barrier to customization. So even there are loads of healthcare NLP applications, loads of data, but they probably not fit the research requirement of the healthcare research conducting. So bear with those barriers. So we are trying to introduce GATE to overcome these barriers. So before I go to more specific examples how we handle it, I will give you a brief introduction about the GATE. So GATE is general architecture for text engineering, which is designed and maintained by the University of Sheffield. So the GATE itself is free and totally open source. So we designed it for easy to use for all level of user with different computer science background, and come with simple graphic user interface, and even like user without any coding experience, they can apply different healthcare NLP applications, and they can adapt the healthcare applications that fit their own research needs, and they can even build the application from scratch. So you are looking at is a screenshot of GATE developer. So the GATE developer provides a framework and numerous essential components we call the plugin for healthcare NLP. Like those components including the pre-processing or language processing tools, for example, like tokenizer, part of speech tagging. And we also provide lots of healthcare specific NLP components. Those components including like biomedical named entity recognition, pharmacotherapy annotation, and gene tagging, all those things. Along with this, we also provide NLP development tools. So we have the learning framework, allows you to apply the latest machine learning algorithm without writing a single line of code. We also have like a rule engine. You can write some rules to fit your research needs. So beside of the GATE developer, we also have the GATE Cloud, which GATE Cloud is kind of cloud-based NLP platform, allows you to deploy the GATE NLP tools and applications. And we have the GATE Teamware. GATE Teamware is a collaborative web-based document annotation tool. Basically, you can apply your own data and do the annotation with your colleagues in the GATE Teamware and apply it to the GATE developer and apply this learning framework to train a machine learning model that fit the research need. And we have the GATE Mimir. Now, GATE Mimir is designed for handle the large data, and is a highly scalable semantic indexing for search platform. So that is a brief introduction of the GATE. So now I will give you an exact example how we apply GATE framework to tackle those barriers. So the example I'm going to introduce here is the NHS Text Analytics Cloud. So NHS Text Analytics Cloud is a cloud-based infrastructure for healthcare text analysis. It's aiming to simplify the large-scale healthcare text processing. So about this cloud, it's based on the GATE Cloud. Of course, it's customized for the healthcare NLP. Currently, it's running 18 different healthcare GATE applications there. And those applications, including finding like positive, negative symptoms, and find the background, patient some background, like for example, education background, HIV stat, smoking stat, all these things. And we have the application find the interventions, for example, pharmacotherapy and psychotherapy targets. And also we have some applications try to find some outcomes. For example, is there any adverse events in the patient record? So as I mentioned, we have over 80 applications there, and this number, of course, is keeping increasing. So here is a screenshot of the text analytics. So if you click any of these applications, you will land to this interface. Basically, you can type or copy text in there and try it out. Also, you can upload your own document. So basically, GATE natively supports most of the document format, including like Excel format, Microsoft Word, PDF, even HTMLs. So the cloud, the text analytics, is backed with the GATE Cloud Parallelizer. So the GCP GATE Cloud Parallelizer will automatically execute the GATE applications in parallel. So, but the user, when user designs the GATE applications, they don't need to worry about the multi-threading, multi-core. So the GCP GATE GCP will automatically consider this for the user. Will automatically apply the parallelization in the processing in the running time. So now I'm going to talk about a little bit how we tackle about this data barriers. So the NHS Text Analytics is connected to the CRIS database. So CRIS database is clinical record interactive search. So basically, it's including 15 million real patient records. This allows researchers to use the real patient records to do their own kind of healthcare-related researches. And basically, this is how it can be works. So if there is a healthcare researcher trying to answer some specific questions using NLP, for example, here is what percentage of lung cancer patients smoke. So basically, he will apply the GATE Mimia, generate some queries, pull out all the document patient with lung cancer. And then this will generate a kind of a virtual database table. And then we will apply the smoke stat application and run through over this lung cancer patient documents. And then this healthcare researcher will get the result. So in this process, this healthcare researcher actually only deal with the text analytic cloud. So patient records is still sitting in the CRIS database. Basically, this healthcare researcher will never see the original patient document. So the privacy of the patient gets protected. But at the same time, he will use their document to do the healthcare researcher, and finally, of course, benefit for the patient. So here is how it can be done in the text analytics cloud. Basically, the people, rather than text or paste or even upload the document, they can click a button to select the data resources. So they just pick the data table from the drop-down menu that's created in the backend. So the last part, I want to talk about the customization. As I mentioned before, we have the GATE developer. So GATE developer provides simple drag and drop NLP design style. So basically, we have hundreds of GATE NLP resources that's sitting in the Maven Central. So you can load them from the Maven Central. Also, you can load them from other third parties. And once you load all the required components, resources, you basically just drag them into the pipeline. If you don't want them, just remove them from the pipeline. And for some of the resources, you probably want to put some parameters in. And the screenshot you are looking at is the GATE learning framework for the classification task. Basically, you want tell the processing resources where you want to store the model, and what are the input, what are the target, and probably you want to put some hyperparameters in there. Basically, once you input all this information, and we call it few-click machine learning training and applications. So also GATE developer also enables the evaluation components. You can evaluate your model in the GATE developer as well. For most advanced users, they probably won't use programming languages, and we have the GATE embedded. So GATE embedded support Python and Java languages. I think those are the most used programming languages so far, and they can programming the GATE NLP applications. Of course, they can combine with these drag and drop components as well. So once user finish their customization or building, the last step is the button called Export to GATE Cloud. Basically, after that, their application, the customized application, will ready to load to the GATE Cloud. And of course, this cloud is connected to the Crystal base. This customized application ready to run the Crystal data as well. So in the same time, we are trying to maintain a community to support the customization as well. So basically, we organize the training. We have the annual training in every summer, and we have mailing list to answer questions the user may have. And for more complex like customization requirement, we also provide the consultancy service. At the same time, we are trying to maintain the long-term relationship with the Healthcare Research Institute. And of course, the NHS Text Analytics platform is not the only GATE-backed healthcare NLP infrastructures. There are other examples. For example, the Medgate currently is designed and maintained by Swansea University Medical School, and Cockstock is currently maintained by King's College London. Cashmoid and CATE Connect are the biomedical information retrieval and analysis platform sponsored by EU. Okay, in the future, of course, we will continue maintain the GATE framework, and we are trying to design a web-based developer which further simplify the customization process. We will continue collaborate with the healthcare researchers and find out what the needs and future barriers they probably have. And this is my last slide. If you are interested in GATE Cloud, or how GATE can be help in the biomedical or healthcare processing, please visit our website. And those are the URLs. Thank you very much.